Welcome to cell membrane transports.
Eye layer is composed of mostly phospholipids. The phospholipids have two main components, the hydrophilic head and the hydrophobic tail. The hydrophobic tail is composed of the carbon and the hydrogen bonds and their chains, and the hydrophilic head is composed of 3 glycerol, a phosphate, and a choline. The hydrophilic head wants to go towards the water because it just loves the water. But the hydrophobic tail cannot swim, so it just goes all the way away from it. So you get this neat little structure over here where the hydrophobic tails are just like meeting in the middle and their hydrophilic heads are just like swimming so they can't cross the water. Bilayer is also composed of things that help with active transport. Because active transport, you need energy or you need a special route. And so with peripheral proteins and integral proteins, it's able to give that extra energy to allow for the transport of like really big things or things that go against the grain, like from low concentration to high concentration. But you also have transmembrane channel proteins that allow for like a back passageway, kind of like a bouncer, you know. You tip that bouncer an extra H2O and they're gonna like give you the backstage pass. Horn is the part that specifically helps water get through the cell. It's kind of like water's main man, your wingman, you know what I'm saying? It allows it to come through here because water is super important in maintaining homeostasis and making sure a cell doesn't get too hypertonic or hypotonic. And it also allows other things like sodium to get through there. And with that little comment, you can tell I did this right before a little osmosis lesson. Thank you for coming to my TED Talk. Also important in noting that because water is such a small molecule, kind of like O2 and CO2, that it just uses passive transport. It doesn't require any energy like active transport does. So it just kind of gets a pass, you know. Also, pertaining to water, vesicles are pretty important because they can absorb water if there's too much in the cell, or they can just excrete it if the cell needs it. Also, fun fact, vesicles have a membrane. What? So it's like a membrane within a membrane. It's like, what is this science? Near the aquaporins, you also have where a lot more cells enter. This is the receptor protein. With a receptor protein comes a extracellular signal. For the receptor protein to work, you need an extracellular signal to come and fit into here. It's kind of like a catalyst with a substrate. You need one specific thing to fit into this other specific thing, and that'll only happen if it fits exactly right. It allows everything into the cell that this says that should be allowed into the cell. So it's really specific, and it's really good at controlling what comes in and out of the cell. Just like how I talked about going against the grain with this over here, and proteins need to help with that. You also have things going with the grain. So if the cell needs more sodium, because, you know, sometimes the outside of the cell, the surroundings of the cell, have a lot of sodium, and you just need to balance that out, then you need to go over here into your entrance, and the cell just kind of lets it in depending on whether it needs it or not, or whether it can expend the energy to put it in there or not. Thank you so much for also visiting my other sponsor's website, Shaky Camera Hands. And thank you for letting me turn this in and putting up with my, at times, very fast talking. Thank you. Have a great Thanksgiving break or whenever you get this. Bye.